Hello, welcome to section 2.5 where we're going to be solving linear inequalities. Super fun. No, I mean it, I'm not kidding. Okay, so first of all, we're going to talk about what they are, what they look like, how do they look like graphically, and how to use inequalities in solving word problems, which I know everybody here loves. Okay, so first of all, let's talk about some inequalities and what they look like graphically, and also interval notation. So there's three ways to write the same thing. Okay, so when you see this here, x strictly greater than a, okay, so what that means is the set of all values that's exactly to the right of a on the number line, but not including a. So that's, they'll have like a little parenthesis. Sometimes when I graph, I use a circle like that, and then I do the graph to the right. So in interval notation, we would write, parenthesis because you're not including that letter A. And then to the right, since it goes on indefinitely, you would close it with infinity. And then you would never use a bracket because you do not include it. So parentheses means everything, but not including that exact point. So here, to define or to represent x greater, all the set x that's greater than or equal to some number A, we would, graphically, they put either a bracket. Sometimes I like to use a closed circle like that, and then to the right because it's greater than or equal to. But interval notation, it would have a bracket and then go on to infinity. And of course, we never bracket infinity because it's not an actual tangible finite number. Okay, so for x strictly less than a, notice that it does not have the line underneath. So it just means all the values that are to the left of a on the number line. Okay, all the values to the left, that's supposed to be a thing. So then the graph goes from negative infinity, because we always write in order from lowest to greatest, and then it goes up to a and stops, but does not include a. All right, for x less than or equal to a, we have all the graph to the left, but then at a, we either do a closed circle or a bracket. And then interval notation, it's negative infinity, comma, and then stops at a bracket. That means, again, the bracket means to include that value. So let's do a few examples here. We have graph each inequality on the number line. And let's write an interval notation. So here you would have a number line at -3. It says equal to, so it's greater than or equal to. So you include -3, and then you graph to the right. The graph goes to the right. And then interval notation would be -3, sorry, this is a -3, comma, to infinity. Okay, so for B, we have x less than 2.5. So here's your number line. And then 2.5 would be here. There's no equal sign, right? It's just a strict inequality. There's no line here. No line here, right? So that just means open circle and to the left. Okay. That's an arrow here. So for C, we have x less than or equal to -3/5. So here's your number line, -3/5. You include it because there is a line here, right? That's the line right there, line. And then you graph to the left. Okay. And you make sure you put in the arrow. Oh, so let's not forget interval notation. So for B, it goes from -infinity to 2.5, and it doesn't include it. So notice that if you have it graphed on the number line, it's easy to go from graph to interval notation. Okay, so here it would be -infinity, -3/5, and then you would bracket it because it's a closed circle or because you included it. Okay, let's do a few of these. Now, these are a little different. Notice that this is all the set x deals with all the numbers between -3 and 4. So for A, you have x is not, it's between 3 and 4, so it's greater than 3, but it's also less than 4. It does not include -3 and 4 though. So you have -3 and you have 4. Open circle, and then just all the numbers in between. Okay, so interval notation would be -3, comma 4. Okay, parenthesis on both. Okay, so for B, we have x is greater than or equal to -6, but also less than -1. So on the number line, you would have -6, -1. At -6, you include it. At -1, you do not. So it's circle, and then you graph everything in between. Okay, and then interval notation, -6, and then -1, do not include -1. Okay, so then C is x is in between and including 0 and 2.5. So notice there's 2 lines, right? So the graph would be here. Let's say this is 0, this is 2.5. You would include the endpoints and then the graph in between. Interval notation, 0, 2.5, include both endpoints. All right. So a linear inequality is basically when you have a line on one side of the inequality and then a constant. So you can have them either be less than or equal to, greater than or equal to. Addition and subtraction property of inequality, similar to addition and subtraction property of equality. If you have something that is, so let's say for example, you have 1 is less than 5. We know that. If I add 1 to both sides of the inequality, I get 2 less than 6, which is still true. So you can add things or subtract things to both sides of an inequality without changing the value of the inequality. The inequality will still hold true. Okay. So let's say here, for instance, you have like 5 is greater than 1. And if I subtracted 1, I would get that 4 is greater than 0, which is also true. So it still works. Okay. Now, what about multiplication? If we can multiply both sides of an inequality, and that's fine. However, the only thing that will change the inequality is if we multiply by a negative. So let me show you with a numerical example. So suppose I have 1 is less than 2. If I multiply both sides by +2, I get that 2 is less than 4, and that's still true. However, starting with the same thing, when this is 2, if I multiply both sides by -1, what happens? Well, on the left side, I have a -1, and on the right side, I have -2. Now, is -1 less than -2? Look at the number line. -2 is over here, -1 is over here. So -2 is less than. So using this would be wrong, so we need to flip it. Okay, so we need to flip it. This has to do with like the opposites and the way that the number line works. Okay, so when we multiply by a negative or divide by a negative, we need to flip the inequality sign. Okay, that's what we need to do. Okay, so let's not forget, let's do a couple of examples. Here we have 3. So for A, we have x minus 3/8 is less than or equal to 3/4. So to solve for x, we would add 3/8 to both sides. Okay, then we would get x is less than or equal to 3/4 is equivalent to 6/8 today. So then that would be 9/8. Okay, so graph on the number line. Graphing is very easy. You just have to put the point there, 9/8. Now it's less than or equal to, so you're highlighting the point and then shading to the left. Interval notation, negative infinity, comma, 9/8, include that point. Okay, so that's this one. Let's do a couple more. B says 9y is less than 54. So to solve for y, just divide by 9. We get the value y less than 6. Okay, what does that look like on the number line? Here, 6. Do I include him? No, I do not. Open circle. Okay, what side am I shading? It's all the values that are less than 6. So I'm going to the left. Remember, less than is left. The numbers are increased from left to right. So on the number line, the lower numbers are on the left, and the greater numbers, it increases towards the right, right? Okay, so interval notation, negative infinity to 6, do not include 6, so we have a parentheses. Okay, so for C, we have negative 15 less than 3/5 z. So in order to isolate the variable, we multiply both sides by the reciprocal, 5/3. So that cancels out. You get z on the right-hand side greater than. 3 goes into 15 5 times today. 5 times negative 5 is negative 25. I can rewrite this inequality in this way, z greater than negative 25. It's just a lot easier to graph, okay? Because here you'll have your point of interest, negative 25, open circle, and you shade to the right. And then you go from negative 25 to infinity. Okay, let me